Hello everyone. In this lecture, we are going to see um, how to write the algorithm. What are the various methods to write the algorithm? Also, we are going to see what are the major important characteristics of an algorithm and where this subject, the algorithm, the design and analysis of algorithm subject is going to be used. Where in the real world we are going to use this subject. So let's move to the first slide. And in this slide, I've just taken a simple problem. The problem is how to add two numbers and print their sum. Now there are four approaches to write an algorithm for this problem. We have to, the task is to write the algorithm. Okay. And the first approach we can do is we have a natural language approach, we have a flowchart, we have a pseudocode, and then ultimately we will write the program in our programming language, whether it can be C, C++, Java, Python, any of the language. Okay, so all these three things, the natural language, flowchart, and pseudocode should be independent of the language used also. Okay, so what is or how to write this problem, add two numbers and print their sum in natural languages. What we are going to do is we see natural languages, the language which are natural to you or your mother tongue, you can say. So let us say I'm an Indian, but my mother tongue, but let me just assume my mother tongue is English. So I'm just writing, okay, let me start. Then let me declare three variables A, B, and sum, and then read values in A and B. Let's say I've read value 10 and 20 when we make our program. I will write 10 and 20. Then we will add these two numbers and assign result to the variable sum. So what result will be assigned? 30. And this display the sum 30. So this 30, we are not actually assigning in this. I'm just writing it. So when we write the program, we will do something like this. So in plain and simple English language, I have told what needs to be done. Okay. And also one more point I want to point out why we are studying this, why I'm making a video on this is because when we go to more complex problem, for example, I have to multiply various matrices or I have to find path in real world. I have to implement some algorithm, some path finding algorithm on Google Map. I have to have a blueprint. Okay, I need to have an approach how to write the program, which data structure to use. So in order to do all those things, I have to have a blueprint. So these are the ways to write that blueprint, the ways to write things before we can write the final program. The second approach we can use is a flow chart. In this flow chart also, we have a start and stop, but we are using a chart to show what the steps we can follow. So in this parallelogram type of box, we have declared the value of a, declare the variable a, b, and sum, and then we are reading values in a and b. A we have read 10, b in b we read 20, and then we are adding these sum. Okay, let's say 30, and then we are displaying the sum. So in the processing, when we are doing some processing part, we have used a rectangle box. Okay, so this is the way we can approach the flowchart way. The next way is we can write a pseudo code. Now, the pseudo code is a very specific code. So you can see there's a beginning and there's an end. And here we have written what we want to do. Just read A and B and then add in the sum code. So this is the way how we can use a pseudo code to write our algorithm. Okay, and then the lastly, we use a programming language. Okay, here we have used a C programming language to write the final output, the final what we need. So this is also one way to write. We can directly write the program. Just think in our head what should be the solution and just go ahead and write the problem. But for more complex problems, we need to use natural language or flowchart or pseudocode to at least figure out how to write it. Okay, so we will encounter them later on, and then we move on to the characteristics of the algorithm. So in all the books you will see they can be more characteristics for sure, but majorly for algorithm, before writing an algorithm, we have to ensure these characteristics are met. So the first characteristic is unambiguity. The algorithm should be unambiguous. What does we mean by this? The algorithm should not have the algorithm should not have two meanings. Okay, it should not have two meanings. Okay, so for example, if we are writing an algorithm for finding a path from point A to B, then it should not uh, do something else at the same time. If the task is just to find the path from A to B, it should not be finding the path from A to C also. If the task is that on, if the task is to find path from A to B and A to C also, then it should do that on. Okay, so the algorithm should be unambiguous in a way. The second point is the input. Now, what is input? Algorithm should have an input. Otherwise, if we do not input something in our program, then what the program can output. Okay, so that is why the second point, it should have an output. If we have an input, we should get some output. Otherwise, there's no point in writing a program. Then there is something called as finiteness. Now, whenever we write an algorithm, we should always keep in mind that the solution should come to us in finite time. Solution should come in finite time. It should not go infinitely. And then solution should be feasible. Let's say I have written an algorithm to how we can launch a plane to Pluto. But it is not feasible right now. It is not feasible. So we have to write algorithm. It should be feasible. The current machine can handle that problem. Then the sixth point is the algorithm should be independent. Now, what should it be independent of? It should be independent of the machine in which we are implementing. The machine independent. For example, if we are using a calling feature, if we want to call a person, so that call is going on mobile also and on smartwatch also. Okay, so it is not like it cannot go on a smartwatch. So as much independent as we make, or for example, or more basic example, if a program, if an application is running on Windows, then that application should be made for all the machines. For Mac also it should run. For Linux also it should run. Okay, so we have to make application for all the machines. It should be independent. So algorithm should be independent of the machine. Okay, then then moving on. Then what are the various fields in which the algorithm is used? So being a computer science and engineering student, or maybe you are from some other discipline also. So in computer science, we all know we have to use algorithm to write a program. So now the computer science is being used in almost every field. We have rocket launches to mathematics to cloud computing. For example, in mathematics, we are using it to find the shortest path in a graph. Okay, suppose there is a graph like this. Okay. And if I just name them A, B, C, D, E, I want to find a path, shortest path to go from A to D. Okay, from this point to this point, if I want to go, I have to write a program. So in order to write that program, I need to have an efficient algorithm. Okay, so in cloud computing, the second point is cloud computing. Now, cloud computing is basically how we can use the internet services with minimum, every service we can use over the internet with minimum failure. We can do that.